Yes, I had one interesting one.
Okay.
So,
Right.
let x be any real number
Okay.
and n be any integer greater than 1.
Okay. Greater than 1.
Yeah. Uh, Show that there exists a rational number p by q
Okay.
with 0, q greater than 0,
Right.
but less than or equal to n. Q is less than or equal to n.
Right.
Uh, yes, so such that
Mm-hmm.
the modulus of x minus p by q
Mm-hmm. Is
is
less than 1 by n.
1 by n q. 1 by n
Oh,
q.
okay. That is different. Yeah.
Right. Yes, sir. So, and q can be equal to n also, like in that with n greater
Okay.
than or equal to. Not cubed, so n q. So it's like that.
Oh, that's what I was thinking, because n cubed would be too much, right? That would be too
Huh,
small, right?
probably.
With just,
Right, right.
yeah, with so much restriction on q, that would be too small.
Yeah.
That's why I was a little confused.
Yeah. And then they gave an example. So like pi, and then they
Huh.
took n equal to 10. So they took 22 by 7
Okay,
for p
that's
by q.
fine. Yeah, right. S-
So my first thought was to multiply both sides by q. So
mhm,
you'll get, and the q is positive. So xq minus p mod
mhm.
lesser than 1 over n. So like that's all. Like I don't know what to do after this.
Right, right. No problem. No, this is so I know this question. This is a standard question. So
Okay.
yeah. Yeah, so what this is, so okay, so I will, so what this is trying to say is the p, now p is an integer, right? Right?
Right. Yes,
P is
sir.
an integer and there is a xq. So basically you see, you can replace this more or less, you can replace this thing by fractional part of xq,
Fractional part. Yeah, yeah. Even I was thinking that. Yeah. Yes,
right?
sir.
And then you want to make this small.
Correct.
Okay, and that you should try to think how to make the fractional part small. But I suppose since you have already thought about fractional part, so you would have thought about it, and so far maybe you have not succeeded. But then the hint is something like this. So the hint is something like this. So there is 0 and there is
Okay.
1, right? And this fractional parts lie in. So basically you have to find some q for which the fractional part becomes small, less than 1 by n.
Yeah.
Right? You have to find some q,
Less than 1 by. Yeah.
right, such that the fractional part becomes less than 1 by n. Now you see, if x was rational, there is really nothing to do,
Okay. Yeah, yeah.
right? It was not needed to be said. There was no need for me to say that, but just for that this can be done for some cases at least. So you already know the answer for some cases. Okay.
Correct.
So for
Correct. Yes, sir.
q it is trivial. Now you realize the question is, and you would know that either ways. So but then basically now we are saying that for q it is trivial, but then sorry, if x is irrational, then what do you do? You see, what happens is that when x is irrational, then when you take the multiples of x, right, you never get 0. The fractional part never becomes 0,
Yeah.
right? Fractional
Yeah,
part
yeah. Fractional
never
part.
becomes 0.
Yeah, yeah.
And
Multiples of x as in like 2 pi, 3 pi, so something like that.
2 pi, no, just, yeah,
No, no,
2q,
like just
yeah,
as an
2x.
example.
Yes, yeah, as an example that will work.
Okay.
Yeah, 2x,
Okay.
3x,
Yeah, yeah. Fine, fine. Okay.
right, like this. And you want to say one of the fractional parts is less. So for this, I mean, there is a good way to say it, but then otherwise you can do something like this. Means, yeah, you can take something like this. You can divide this number line Okay, like this.
Okay.
And so you see, I have divided it into how many parts, whatever, and how many parts? N parts, right? Yeah, correct. It is N
N,
parts,
N.
and each
Yeah.
of them has size 1 by N, hence. And now you want to basically show that two, I mean, if you can show that two multiples, right? So we want to show that there is a K1 and K2 such that K1Q and K2Q, right? They are both
Hmm.
inside some, some M by N and M minus 1 by N.
Okay, so it's basically done. So we have Q lesser than or equal
Yeah.
to N. So then the only multiples we have to consider are fractional part of 0x, fractional part of 1x, all the way up to fractional part of nx.
Yes. Yeah. And then
So
in
there are
that
n plus 1.
you will find 0x. No, 0x. I don't know.
Oh, yeah, q is greater than 0.
Yeah.
Never mind. So
You
yeah.
can see those will be some small cases which you can work out. Okay. So I will leave
Okay,
that to
yeah,
you.
yeah.
Okay. Yeah. Some n and plus.
Right, yes.
So then this is done. Okay.
Yeah,
Right.
this is done. Yes.
Yeah. What this is saying is something actually more. So mm, yeah. What this is saying is something like this, that if you if you don't take the fractional parts, so if you don't take the fractional parts and just take this, okay,
Okay, yes.
then then you can show that this set is actually dense in R. And what do I mean
Okay.
by dense? I mean that basically given any, and you can try to prove this, you should prove this, given any, because this comes up in all kinds of forms, this kind of question. Okay, so basically what this is saying is that given any point and then given any interval, no matter how small, there will be something from this set, there will be some tx sitting in that.
Where t is an integer
Yes, yeah. So maybe t is,
and x is irrational.
yeah, x is that fixed irrational, right? X is
But
fixed,
how so like if you have, suppose we take x as e,
right?
then 2e and 3e. So like between those, we can make some interval small. You'll not have an integer
You will
multiplication.
not have an integer, right? No, so then this is not what I wanted to say. Um, no, certainly this is, I mean, this is obviously not dense. This is an arithmetic progression. Yeah. Uh,
Right. Okay.
so what is supposed to be dense then? Just a minute.
Yes.
Yeah, something I just forgetting. Anyways, so okay, certainly what you can prove maybe is the following. Yeah, you can prove that if you take the fractional parts, right? If you take the
Right.
fractional parts only,
Yes, sir.
yeah, then this is actually dense in 0, comma 1.
So dense in the unit interval.
Yes. So basically
Okay.
what this question is asking you to show is that it is dense around 0.
Hmm.
Right.
Okay.
Around 0, if you take any neighborhood, then you will find some fractional part inside that. Obviously, it's asking a little bit more, that q cannot be that big. Okay. But otherwise,
Yeah.
this is what it is saying. That is dense inside 0, comma 1. Yeah, so it cannot be dense in R. It's dense inside 0, comma 1.
Yeah, but how would you like prove this? Like it seems very Like, like
No, so
at first glance, I don't know how to.
no, but just the way you prove that it is dense in zero, it's dense around zero. In the same way, you can prove it.
Okay, so I'll try
Right.
this. Yes, sir.
Yeah. So I mean, if you already proved one case, right? You already proved that one case. But
So for
then,
any
uh,
I, which is an interval, which is belonging to 0, comma 1, I have to show that for every rational, this set, like you can find an element from this set inside that I.
yes, yeah,
Okay,
you have
okay,
proved
yes,
it
sir.
around zero. Now, if you just prove it around any point, okay,
Yeah, okay.
right?
But now I don't have this restriction that like it has to be less than n or so. So maybe I
No,
can do
you
it.
don't
Yes.
have that restriction now. You don't have that restriction now. Okay.
Okay.
But then,
Yes, sir.
but then one can quickly, I think, tweak this set
Also,
and
I
make
think you can
this.
just generalize this. No? So, like we have shown that if we divide 1 by n into n part, it is the unit interval into n parts,
Mhm.
then it suffices to have, till nx. So like that we can divide into 1 over n plus 1, n plus 1. So like that we can keep on dividing no matter how small you make it. Like you
Mhm.
can always find a some interval where you have some n plus k numbers of this form
Mhm.
that is in that, like same generalizing this thing, like
No, but when you take the difference, it again goes to zero, I think.
oh,
Eventually, you have to take the
okay,
difference of those two numbers. Yeah,
correct, yeah,
yes.
yeah,
So you have to think about this. Yeah. But then I think quickly one can tweak this set and make it dense in R. So
oh,
how should one do? I think if you just take this set and add integers, yeah, if
yeah,
you
then
add,
it'll be,
then it will be dense in R, right?
yeah, so
And
yeah,
that is
correct. So if
easy.
you add like k, it'll be dense in k to k plus 1. Yeah, yeah,
Yes, so then you are right. Then this is dense. This is the set I was talking about. Okay. That you take the fractional part and then you add arbitrary integers, not just the 2x, but 2x plus 1, 2x plus 2, 2x plus 3. Right. Right. That is it.
right.
Yeah. Basically, I don't even need to say this fractional part, right? I can just say that this set n alpha plus z
Yeah,
as a set means all possible multiples of alpha and then adding all possible integers. This becomes dense in R. And this has many consequences you will see even in elementary questions. But then there is another direction to these questions, which I just want to have a look, which is not generalizing this in the language of dense and so on, but trying to make this make this thing stronger. So basically, you have picked Q between 0 and n, and you have gotten a fairly good approximation.
yeah. For
Right,
the irrational.
right.
Yeah.
Yeah. But then notice one thing that if you have an irrational, it's a very small thing. If you have an irrational x, right, and you put this restriction on q, that the denominator of q cannot be more than n, okay, then
Yeah.
then it means that you can, I can say like that it forms a discrete set. But uh, what I'm trying to say is that then I'm saying that there exists some neighborhood around x in which there is no number of the form p by q with q less than n.
Okay.
That is intuitively clear because q less than n, there are only finitely many numbers.
Yeah,
And
correct.
p
So,
also
but
less
we can
than,
make this like infinitely
yes,
small.
yes. And these things are also very useful. So basically, the point is that you cannot expect better and better approximations if you fix your q, if you put a condition on q.
Yeah. Like, yeah, at some point,
You
like
cannot.
what?
Yeah, at some point you have
Yeah,
to
correct.
you have to let go q a little bit also. Okay.
Yeah, correct. Yes, sir.
Yeah, that is right. But then there was a problem in this. So have you heard? You may have known this book called by Kaczor, right? Problems in
Mm.
mathematical analysis.
By
So the name of the author is Kaczor, and another author is
I think I've heard of it. Yes.
another author is Novak. But most of the problems with this book are very difficult. They are like,
Yes, you told me about this one, I think, before.
yes, I had told you about this, right? So here we can just have a look at the book itself. They had some questions along these lines where they obviously go and generalize it and so on, but I do not remember how they do it. There are these other interesting dense sets. You see cos n minus 1 to 1, that is dense. Okay, and you see this
Okay,
is the
so you
question
can
I was
find.
talking about. This
Oh,
that this
all right,
becomes
right,
dense
right.
in R. So by knowledge comes from. But obviously now we know it through other things, but never mind. Yes, yeah, but they only do these two only.
Oh, so this is the actual. Oh, this is the same question.
It's almost the same question. It is the same
No,
question.
no,
You're right. You're right.
QN. Yes, sir.
For
Yes,
every
sir.
n, they're
Yeah.
asking it in terms of sequence, but it is the same question as you notice. Yes.
Right.
But
Yes,
then you
sir.
see, they are asking you to prove this. Okay.
Q squared.
Yeah. But this is actually easier, right? Because actually this is less than this, right?
Correct. Correct. Yeah.
Q is less than n. No, no, sorry. Am I saying
Mm,
something wrong?
j-
No, no, I'm saying something wrong. Yeah. No, this it cannot be. They are not stupid. I think they won't give this easier question, right?
right.
So yeah, so Qn is less than n. Yeah, if the way we did the problem, the Qn was less than n, but then that means that 1 by Qn. Oh no, no, no. I think I think we are correct. Yeah, yeah, we are correct. We proved this. Yeah, I mean, yeah, it is less, so it's better, right? So this is actually less than 1 by
Hmm.
Qn square, of course. Yeah, and so yeah, so this is fine. Okay, so they don't have any other interesting variation, at least so far, but they may have later. So you can just if you are this is not mandatory because everything has generalization, right? So it's not really. Yeah, these things I don't know, these are probably different set of questions. Okay, right here you look here.
Right. Yes, sir.
Okay, so they use all this these things to get here. So
Okay.
you can have a look at this later. Since I am out of time, running out of time, otherwise you can look because they want, you see, they want the Qn to be odd. That's the
Oh.
only other thing. They want the Qn to be odd. And for I had done this question at some point. You have to study this. You have to do this continued fraction thing because in continued fractions those kind of things happen. Yeah, right. And there are other questions which actually is similar,
Right.
interesting. So you can look at it basically. Yeah. Okay. Right. And
Okay. So
yeah,
I'll download the PDF.
yeah, you can download the PDF. If you have any library nearby, it should be there if it's a good enough library. Otherwise, you can download. Do you have any libraries? You don't get the time
Yeah,
maybe,
yeah.
right?
There is one. So I think a newly opened one.
Okay.
Uh, so I National Library or something like that is called. So it's a big library. So it must be there.
Yeah. If you go
So
to, do you ever go to library or you study at home?
no, no. So I go. I actually have a membership at a library.
That's good.
Uh,
Yeah. Means it
right.
doesn't need to have books. It doesn't need to have all the math books, but if it's just a peaceful place to study or whatever, it's good enough sometimes.
Yeah. Yes, sir.
Yeah. Okay, then let us stop here. Then let's meet next time sometime. So I'm planning that on Tuesday I will